Hey coders, how's it going? So today actually we're going to be looking at sorting algorithms, right? So this includes selection, bubble, insertion, merge, and quicksort. So I thought this will be a good idea to kind of like walk you through all the sorting algorithms so that you can see their differences and you can see which ones are efficient and which one are not efficient. And this will actually help you in an interview because usually they want you to write efficient algorithms. So how can we go about this, right? So the first one we're gonna start to look at is actually selection sort. So selection sort at the high level, what I can say to you is that if we are given an unsorted array, so what we need to do is that we need to take all the small element and just make sure that they're all at the beginning. So let's say we have an array of 5, 3, 1, and 0. So essentially is to make sure that the first loop that we're gonna run is to get this 0 to come to the first index. Then we do the same thing is to get 1, make sure that it comes to 3, right? So we just do that iteratively. So from code perspective, how can we write an algorithm like that? So we can actually loop through for I in range of length. We can actually loop through this unsorted array and we get the first index. Then we just need to change it. So by first index, I mean we need to get the first index, the I, which we're gonna make it the mean value. So I, at this point, I is going to be 5. Okay, so we just need to change it based on which element are going to come after it. So that means we're gonna have to have the second for loop whereby we're gonna call it for I, for J in range. So I'm just going to copy this just to kind of like save time. So because we know that we want to start from the second element going forward, because obviously here we already have 5, right? So we want to get this 3. So how can we do that in Python? Essentially we can say something like I plus 1. So start from the index I, which is 0, then add 1, then it's going to start from 1 going forward. Okay, so that's just the technique that we can use. So while we're inside here, we want to know that this first index is actually greater than the next element. If that's the case, then we want to change the mean value to be this index here, if that makes sense, right? So you want to write something like if unsorted array dot mean value, okay, if it is greater than unsorted array J, which is the second value, so it's like me saying is 5 greater than 3. If 5 is greater than 3, then I want to change the mean value. Yes, I want to change the mean value because 5 is no longer mean. 3 is going to be our mean value. So it's going to be mean equals to J. Okay, so you can imagine this is gonna go through, it's gonna go through this loop and just keep on changing this. So it's gonna go through, it's gonna come across 1, it's gonna come across 0. So the mean value by the end of the day, by the end of this for loop, right, is gonna be 0 because that's the minimum value. What we need to do now is that we need to then swap these elements. Okay, so we have to swap the current element that we add, which is, we know by this for loop, we are currently at 5. So the mean value that we currently changed to 0. So we just need to swap it. So in Python, to swap the element, you can do unsorted array, and you can take the mean value, and you can actually say equals to unsorted array, and you can point it actually towards I. So I, we know that it denotes 5, and the mean value was actually changed because we assign it to J, so it denotes 0. So what we're saying is that we're saying take whatever is at the mean value, which is, we know because we have been changing it, which is 0, we're gonna set it to 5. Similarly, we're gonna say take whatever was at 5 and set it to 0, something like that. Okay, So in Python, this is how you kind of like swap values in on the same indices. Okay, so now what we're gonna do is that we're gonna print our unsorted array. Because we know it is like this, so we expect to see it sorted now. Like we expect to see 0, 1, 3, 5. So it's still running. In the meantime, we can move to the second sorting algorithm. It's also called, I think I didn't actually indent very well, so let me just fix that. So it works, right? So we're able to sort this array. But however, the time complexity of this, so it's not a very efficient algorithm to sort, okay? So the time complexity of this is going to be n squared, right? So it's not efficient. However, we're able to sort this in place, meaning that this is going to give us the space complexity of 1. Because we did not create any index, so the same array we sorted in place. Okay. However, still is not efficient. Now look at bubble sort, right? So bubble sort essentially is quite similar to selection sort. Instead that with bubble sort, we instead of moving small element towards the beginning, we move large element to the end, if that makes sense, right? So you can think of like we're gonna look through the entire array. The reason I'm using underscore, this shows that I'm not gonna really use this. So I'm really gonna focus more on the I index, which we're gonna create with the second for loop. So what I'm gonna do is that I'm actually gonna copy this array because we're gonna reuse it. So we're gonna take this array, but we're gonna take the length and we're gonna say unsupported array. And what we want to do in this case is that we want to create a second for loop, and it's going to be for I in range of length unsupported array, and we're going to -1. So the reason I'm subtracting 1, so I'm looping from here to here, is because the last element is going to always be sorted. Like, right, that's the only single element, so we don't necessarily have to look at it and try to kind of like sort it, right? So that's why I'm not really gonna focus on it. But this is the most important thing, right? This is where kind of like the logic comes in. So what you want to do is that you want to take the first element and you want to look at the next element. You want to check if 5 is greater than 3, right? If it is, then you swap this element. Then you do that again, you look at that 5, it is greater than 1. Right, okay, let's actually do it in real time so I kind of like understand what I'm talking about. So you look at 5, you look at 3, you look at 1, you look at 0. So the first thing that we do, we're gonna write code now. We're gonna say, is 5 greater than 3? Yes, it is. Then swap these two things together. So 3 is gonna come here and 5 is gonna come here. We ask the same question, is 5 greater than 1? Yes, it is. Then swap these two elements. Then 1 is gonna come here, 5 is going to come here. Is 5 greater than 0? Yes, it is. Then 0 is going to come here and 5 is going to come here. We go back to the main for loop, right? We go back to the main for loop. So the main for loop is going to come again, do the same thing that we just did. So in code, how can we do this, right? We're just going to say if unsorted array, which is I index, it is greater than the next element. So you're gonna say unsorted array I plus 1. Then if it is greater, then you wanna sort these things. So you're gonna say unsorted array. You take I, you're gonna say equals to unsorted array. You're gonna say I plus 1. So to swap elements in Python in an array, so you have to like use this technique. Usually in different programming languages, what you will do is that you will create a dead variable. You can call it temp, which is going to call the current variable. Then you kind of like that's how you swap. But in Python, you can actually do something like this. You can say, you can do it on one line essentially. So you can say +1, and this is actually going to sort in place, right? Sorted array, and you're going to say for I. Okay. So I hope that makes sense. Whatever was here at I is going to take the position of, just like I showed you here. If it was 5, 5 is going to take the position of 3, and 3 is going to take the position of 1. Okay, guys. And I think that's all essentially with this algorithm. Yeah, because we're doing this in place, so it's not a function, so we can actually print this out and see how it actually works. Just gonna copy this and paste it there and see how we're doing this. So it also works, right? So essentially what I can tell you is that for you to kind of like remember the difference between selection and bubble is that with selection is that we take the minimum value. They both have like the same time complexity, but the algorithm essentially they differ because of the selection sort try to push the small element towards the beginning, right? Because as you saw here, we try to get that 0, and after we get it, then we kind of like swap them again. Then we go through the for loop again, right? We go to the next value, but the point is that we get the small value, push them at the beginning. Whereas with bubble sort, we get the large element to push them at the end, right? For example, we check if 5 is greater than the next value. Yes, it is. We push them until it gets to the end of the array, right? So it's also not efficient. It wouldn't be accepted in an interview to write this sorting algorithm. So there's a time complexity of O of n. N squared, I mean to say. Sorry about that. N squared, and denoting the number of elements. So the space complexity also, because it's sorting in place, then the space complexity is going to be O of 1. Okay. Yep. Just for your reference, I'm going to upload this on GitHub. So let's look at insertion sort. Insertion sort is very different from both bubble and selection sort. So insertion sort essentially like works with what can I say, with boundaries, right? So I want to go to whiteboard and kind of like explain to you what I mean by this. So let's say we are given an array. So I'm just remove this. So let's say we're given an array, and this array contains unsorted elements, right? We can think of it as 5, 3, 0, 1, you know. So with insertion sort, we're saying that all the elements on the left are sorted, and all the elements on the right are not sorted, right? So which means that the first element, because there's only one element, so this one is sorted. So essentially we need to look from element 1, right? Assuming that this started 0, 1, 2, and 3. So we're gonna start from this. And what we do with insertion sort, we think of this as a whole, right? Because we're gonna ask ourselves, is this element that we're currently on, it is greater than, let me say less than the previous element? If it is, then we know that we need to take this element and put it here, right? So to put it here, we need to save it inside a variable. So we're gonna say value equals to 3. So you can think of this, we save it inside there, right? Then, because this is less than the previous element, we need to take 5 and override 3 by 5. So you can think our new array essentially is going to look something along these lines, right? Now, we know that our boundary essentially is going to be sorted. So we're going to have a boundary that's going to start here. But what do we do with that 3? Essentially, we're going to have to take 3 and override it back here. So this 5 is going to be removed. Oh, not this 5, I meant to say this 5 is going to be removed, and we're going to write 5 here, 3 here, and 5 here. So I think you want to understand it very well when we go to the code. So just stick with me. So just know that we're just saying all the left element are sorted and all the right element are not sorted. Then we just work with this boundary. This boundary is going to come here, and similarly we're going to make sure that 0 start here, and 3 and 5 will then be shifted because we're going to create a hole here. Okay, by hole I mean a space, a position that has to be filled. So cool, let's go to the code. I know that I might have confused you if you don't know what is insertion sort, but when I write code, I think it will definitely make sense. So just stick with me. So I was just trying to like give you a high overview of what is it doing and what is the technique at the high level. So with insertion sort, the first thing that we're going to do is that we're going to say for I in the range. So like I said, because of we assume that the first element is sorted, because we know that we treat all of the left element as sorted and the right element is unsorted. So which means that we just about that. So we just need to say for length in unsorted array. From here we just need to start from 1 because we don't have to start at 0, right? So this is actually gonna start at 3 up to the last element. Okay guys, so what we want to do is that we want to create a hole. So the first element, there's gonna be a hole there whereby 3 is occupied. So we're gonna say hole equals to I, and we're gonna say the value equals to unsorted array occupy the element as at I. So it's gonna take this element 3, and similarly the hole will actually be occupying this point. Okay guys, so what's next? The next step is to say while hole is greater than 0, because we know that hole will never be at position 1. We spoke about this, that the first element we assume that is sorted because there's only one element, right? Like one element is sorted, it's fine, there's only one element. So what we want to do is that we want to check if the element behind the hole it is greater or it is greater than the current element. So what I mean is that I'm saying is 5 greater than 3. So how do we access 5? We can just say unsorted array. We know that hole is occupying 3. We just need to say -1. So this is going to take us back to 5. And when we get to 5, we just need to say it's greater than the current value, which is value, right? Now, we're going to have something like this. I'm just going to create this just for your reference and so that you can understand what I'm trying to do here. So we have 5, we have 3, we have 0, we have 1. Okay, we have 1, we have 0. So now, because we know that 5 is greater than 3, so we want to overwrite this 3 because it is small. We want to take it backwards, right? So how can we do that then? We can take unsorted array and say whatever you're pointing at, which is hole, because we know hole is pointing at 3, we want to say equals to the previous element, which is 5. So how can we get 5? So we just have to say this element here. No, just copy and paste just to wait to save time. So we're just gonna say current element point towards the previous element. So it's more like saying 5 and 5, right? We just said 5 override 5. But then we have something new that we also have to do. We have to take hole backwards. So we have to decrement hole, right? So why are we decrementing hole? Because obviously we want to bring 3 back here, right? Because obviously 3 is not here. So if we decrement hole, we can imagine that this condition is not going to be true. So because it's not going to be true, what will then happen is that we need to go outside of the loop, and outside of the loop, then we need to say unsorted array at position, the second position, which is hole, equals to the value, if that makes sense, right? So this element 5, this element here, whole, has been decremented. It was initially 1 and we decremented it. Now it is at 0, and we're saying because it's at 0, so we're gonna write 3 there, because we're saying whole, which is, is pointing at the first element. Then we're gonna give it 0. We're gonna give it this value, which is 3. So 3, that means it's gonna come here. Okay, cool. So let's try to see if like the algorithm is actually working, right? So I know that, guys, insertion sort can be quite confusing at first. Maybe I might have confused you more, but if you kind of like still confused at this point, I'll encourage you to watch this video more again, or another thing that you can do is that you can watch other tutorials. I think you will kind of like get the concept as you go on, right? So it's normal if you don't understand at first. It's very normal. I also kind of like didn't understand this at first. It used to confuse me to kind of like grasp the concept. Okay, so it looks like it works. So now we're gonna move to the second algorithm called merge sort. So merge sort, now we're getting into algorithms which are more efficient, right? So merge sort is actually efficient algorithm. So we can sort an array with the time complexity of n log n. Okay, n log n. So it's quite efficient. However, it has the space complexity of O of n because we need, after we merge the element, we still need to add them inside a specific array, right? So essentially a merge sort, it's a divide and conquer algorithm whereby you can think of whereby we have an array, then we split this array into like 2 components, and we try to sort those 2 components, and we just, after we sort them, then we just kind of like merge these sorted element, right? So I think if I write code and I walk you through each line by line and I take you to whiteboard also, I think it will definitely make sense. So while we're still on whiteboard, just to kind of like explain merge sort to you, just create a space. So we can think that we have an array consisting of 7, 6, 3, 2, 9. So like this, right? So with merge sort, the first thing that we're gonna do is that we're gonna split this array into 2. So you can think of this array, we're gonna split it like 7, 6, 3. Similarly, 2 and 9 is gonna come this side, right? Because we split this recursively. So what will happen is that we're gonna split until we get to a single value. So we can think of this is gonna be 6 and 3. Here we have 7. Similarly, this is gonna split to 6 and 3. Okay, and here we're still gonna be having 7. So when we have one element, when we have a single element, we then merge this. But as we merge them, we make sure that the small element is on the left. So meaning that 3 will come here and 6 will come here, right? Then here we're gonna be having 7 again. Then we merge these again, which means that we're gonna be having 3, 6, and 7. So essentially, like I said, this is a divide and conquer algorithm whereby we take a huge problem, then we divide it into sub problems. Okay, then every time we kind of like have this one element, then we kind of like join them here. So we're gonna do this recursively. Cool. Go into the code. As usual, we're just gonna get our array so that we see if whatever we're gonna write actually works. So just stick with me. I'm gonna explain everything line by line. So the first thing that we're gonna do is that we're gonna create a function called merge sort, which is going to take an array right? Just like I explained to you now in the whiteboard that the base case essentially is gonna be one element. So if we have one element, you can't sort it, right? Like there's only one element. So we have to return that element. So we can say if the length of nums is equals to 1, then we're just gonna return nums. Okay. The second thing that we have to do is that we need to split the array into half. So that means we need a mid number. To get a mid number in Python, essentially you need to say length of nums, you divide by 2. Just to kind of like show you from an example, let's say we have an array of, just gonna create nums equals to, let's say we have an array of like 1, 2, 3, 4, 5, and we want to get the mid number, or rather like, yeah, the mid value, right? So you can do something like nums, the length of nums, length of nums, and we're using this symbol so that we don't get the decimal, so that, because obviously we have to subset using these integers, that's why we're using this symbol here. But anyway, because I'm explaining, you will be able to understand. So here the mid number is 3, so is 0, 1, 2, 3, so it's 4. So if we use something like 4, we can actually use this mid number and see what we get. So we set 3. Perfect, it's 4. So that's essentially what we're doing here. We're just getting the mid number, because like I told you, we want to split the array into 2, right? We're dividing the array into 2, right? So we're gonna say left equals to, we're gonna take nums, and we're gonna say starting from the beginning up to the mid number. Similarly, we're gonna say right equals to nums starting from the mid up to the end. Okay, so we have 2 arrays that we just split, which is left and right. Now we need to take these 2 arrays and we need to pass them through a function called match. So the match function is going to be the one that actually, when I explain in the whiteboard, it's going to be the one that looks at these 2 arrays and look at their first element and try to determine if is the first element greater than the second element on the second array, or then you kind of like swap them, something like that. But as we go on, you will see, I will explain in more detail. So here we're gonna have matched left and matched right. Then you're gonna say match, we're gonna create a function called match, which is going to take left, and we're gonna create another function, it's the same function, we're gonna call it right. Okay, so we're gonna create that function, but for now I have to return I have to take all of these match functions and put them into, oops, what am I doing? It's a recursion, so I have to say match sort. Sorry about that, guys. I have to take these 2 arrays and pass them through a function called match sort. So it's going to be match, which is essentially going to take this left and right array. So this function has to sort these 2 elements. So here I can say sorted equals to, and we're gonna return sorted array. Okay, so we're splitting the elements into 2. We're passing them through towards a function called matchSort, which is this function. So you can see that this is a recursion. So what will happen is that it will take an array and split it again, just like we did in whiteboard, right? You saw we take an array, right, and we take it through this function, through a recursion. This recursion is going to split it again, and it's going to go inside here. The same value is going to come this side. It's going to be split. So this will continue to happen until we get one value. As we get one value, then we're going to return. Similarly here, we're getting one value, then we return. When we return, these things are getting joined together. Okay, So that's what we do. We said if length of nums equals to 1, so we know that this array has only one element is going to be returned. It's a recursion, right? We're calling this function on a subset of this array after we split it. I hope you understand recursion. If you didn't understand recursion, then this might be quite difficult to grasp. So now we know that we need to pass two arrays inside this match function because we called it here. So it takes two arrays because it needs to join these two arrays. So it's going to be left and it's going to be right. So the first thing that I want to do with this is that essentially you have to like loop through the element, and you have to look at the first element on the left subtree and look at the element on the right subtree, right? And try to figure out what is the largest value, right? So let's think about this way. I think you will actually be able to understand. So let's say we have 1, 2, 3, and we have a second array which is called 1, maybe 5, 6, something like that. So if we're gonna try to compare the first value, what is the greater value here? So the greater value is 1. Then we add it into 1. Then we move, we check. What is the greater value here? What is the smaller value here? It's 2. Okay, we take 2. We move. Then what is the greater value? Okay, it's 3. We add 3. Then when we are done, we have exhausted everything inside here. Then we just take this and we add it inside here. So essentially, we're going to have, I'm going to call right, let me just say left and right equals to 0 and 0, right? Which denotes how we're going to iterate through these two elements, right? So I'm going to say while while left is less than length of left, right? And right is less than length of right, right? So what we need to do then is that it's simple now. We just need to check because we just want to check the first value in left and the first value in right. If what is greater, if like the first value in left it is smaller than the first value in right, then we're appending it to the list. Where is that list? Then we're just gonna create this list here, which we're gonna call match. So we're gonna say if left L sorry about that, is greater or equals to right I have to say less than because obviously it's less, so we want to append it. So let's say meshed dot append. We want to append this element here at this point in time, right? Then I'm gonna increment, just like I showed you. After we added this one, we go to the second element. So we're gonna have to increment L plus equals to 1. So when it's else, let's say for some reason we had 5 here, right? So we know that this element is not less than this. 5 is not less than 1. So what will then happen is that we're gonna have to go to this array, take 1 from this array. So similarly, we're gonna say meshed dot append. Okay, we're taking from the right. We're taking from the right. So we're gonna say right. Okay, I can't type today. Oops. Okay, we're taking from the right. We're gonna take right R. So which is gonna give us the first element. So it's gonna say right plus equals to 1. Okay, hope that makes sense, guys. So now think about it. We're always gonna have remaining element, right? Like I showed you in this, we are supposed to match these two arrays, right? 5, 2, 3, and 1, 4, 5. But because we had 1 inside here, we couldn't match them both. So because as we go on, you can imagine that this left is gonna be here, and we only added these ones only, right? So after that means that we need to match this part with this. So we're gonna add these two. Okay, so how do we do that? This has to go outside of the for loop because we know that we have reached the limit of left or right, depending on which had a smaller value, something like that. So we're gonna say remaining, we're gonna call this one remaining left, whereby we're gonna take the left element which are remaining. So we're gonna say left, it's gonna be from left above, okay, and we're gonna say remaining right, it's gonna be right above, okay. So this is gonna give us all the remaining values inside the list. So we just need to say return matched, right, plus remaining left plus remaining right. Okay, so this is the algorithm essentially. This is what we needed to do. So what I'm doing here essentially is that I'm saying, because we know that we'll never exhaust the both arrays, because we have an if else statement, meaning that if the left element is smaller, the first value on the left element is smaller, then we're going to add that element, but then the right one won't move, right? It will still be the same. It won't go anywhere. This will keep on incrementing, and as we continue, we're going to be increasing L, not right. So you can imagine that if this reaches the limit, we still have values in the right array. So what we do then is that, okay, we're taking the remaining, we're taking all the remaining. If there is no remaining, it's fine. It's fine. It's definitely fine. Then we add all of them, including all the elements that we added in the match. Okay, hope that makes sense, guys. So we just need to call match sort, right? I'm gonna call match sort, and we're gonna call it on the unsorted array that we just created here. Gonna be this, see, and it works, guys. You see, so good, right? So essentially, this is what you are required to, if you're gonna like sort in an interview. Maybe you go to lead code, they want you to sort sorted array or something like that. This is what they want to expect you to write. This is an algorithm that they might prefer. If they specify that they don't need they don't care about displaced complexity, right, then you might actually go for this, right? So it's very efficient compared to the previous trait that we wrote. Okay, but there's another one which is more efficient, which is called quick sort. This is what we're going to be looking at now. So the reason it's efficient is essentially still have the same term complexity as match sort. However, it has a space complexity of 1. So with match, you saw we created this array here. We needed to add all of these elements inside that match. So this, we added elements inside our memory, so that is not good. But with match sort, we say we don't need a memory. We can actually match this in place while we still maintain the term complexity of n log n, right? So the space complexity here is going to definitely be O of 1. Let's just warp to the whiteboard and try to understand the concept behind quicksort, right? So quicksort is essentially a divide and conquer problem, right? So what we try to do with quicksort is that we're trying to like take a problem and we're dividing it into like sub problems, right? So these sub problems, they try to arrange or sort these numbers in place, right? And then we match all of these sorted values, then we solve the problem. Okay, so the first thing that I want to do is that I want to introduce a concept in quicksort which is quite important. which is called partition. So it's nothing fancy. It's just to say we're gonna select a pivot. So a pivot, you can think of it as we just selecting a random number. It could be 4, 5. However, this number must be in the array. Okay. Then what we do after we selected the pivot, we make sure that all the numbers that are less than the pivot are on the left side, right? And all the numbers that are greater than the pivot are on the right side. Okay, so like I said, if we can imagine that pivot was 4, that means we're going to be having numbers such as 3, 2, 1, and 0. Then on the right side, we're going to be having numbers such as 5, 6, 7, 8, something like that. Okay, then after we've done this, we just need to divide and conquer our problem. So we're gonna call we're gonna call recursion. So we're gonna call this values here, which is we're gonna call these numbers here because they've been sorted. So it's gonna be 3, 2, 1, 0. Then we do the same thing that we just did. We select the pivot. Right? If our pivot is 0, then we're just going to do the same thing. We're going to say all the numbers that are less than 0 on the left subtree, which there is going to be nothing. Then all the numbers that are greater than 0 on the right subtree. So it's going to be 3, 2, 1. Right? And we do the same thing. 1, same thing, literally. So we just keep on doing this. We just keep on doing this. And we can imagine that we're going to get to the point whereby there's only one element. And when we get to the point where there is only one element, then we return. Right? But the point here is that, as you can see, because of we positioning these numbers from small, all the small numbers are going to be on the left side and all the last values are going to be on the right side. You can see where this thing is going. So we're going to, we literally sorting this, like as we keep on going this, right? So similarly, all of these numbers here on the right side, they will also go through the same process whereby they will be sorted on recursively. Okay. So I think like that is the most important concept. Other than that, I feel like you're just going to understand everything since we covered the method. If you don't, let me know. Maybe I might actually go through this again. So like I said, the first thing that we're going to do is that we're going to create a function called quicksort, whereby we're going to take the first index, right? You can think of this as 0 and the length of the array, which is, we're going to call that R. Then we're going to take the nums, which is the array itself. Then we're going to say if the nums, meaning that we hit the base case, if the nums, the length of the nums, oops, I can't type today, equals to 1, then we want to return nums. Okay. Then we say if L is less than R, right? So you can, like I said, left represent the first index and R represent the length of the array. So we don't want these two things to overlap. So if they overlap, that means we're going outside of the array, meaning we're just going inside in the world of invalid, right? So we don't want to go there. So we always need to kind of like maintain the value, the elements inside the array. So we're gonna start by getting the p index, right? So like I said, the first thing that we do is that we're gonna call the partition, right? The partition is a function that we're gonna create, which I'm gonna walk you through more in thorough details, but essentially it's gonna give us the p index, which is a value that is a pivot. That's what it is. It's just that after we select this from the partition function, it has been all the values that are greater than this pivot are on the right side, and all the values that are less than this pivot are on the left side, right? So you can think of this as L and this as R, and we're giving it nums, okay? Because now, like I said, this is a divide and conquer problem. What we need to do is that we need to go to the left recurse to the left and recurse to the right. So, which means that we're gonna have to go from select the element from the starting array. So just to make an example, we have an array like this, can think of, let me just make it easy for you. I think even if we make few numbers, it's fine. I'm just gonna, perfect. So let's think of it this way, right? We have all of these numbers inside here. So what we're doing is that we're gonna give these numbers to a partition. Partition is gonna select a pivot. In this case, like I said, it's a random number, but usually we select the last element. So let's say we selected 4 as our partition. So now, because we selected 4, what does that mean? It means that our array will be recreated. So we're gonna have 4, and all the elements that are less than 4 are gonna come this side, which is 1 and 2, 1, 3, and 6 will be this side, right? So this is going to be our new array after coming from here. And what is the p index? The p index will be 4. Okay, so what do we do then from there? We're saying take all the elements from 1 to 3 and do the same thing. So that means that we need to have a p index here to say p index minus 1. Okay, so from here we want only these elements, right? So I'm just gonna copy them just for you to understand, so that you can see how this is going to go through a recursion. We're gonna select these 3 numbers here. Okay, we're gonna pass in the same numbers that we had. Then I'm just gonna call quicksort. Okay, then we're gonna say p index. This time we wanna start from here because we wanna take these 6. Also, it's kind of like it's a divide and conquer, so we wanna solve this problem into like sub problems. So go and sort 6, go and sort these 2, just like that, right? So here that means we're gonna have to say p index plus 1, and we're gonna say r and nums. Okay, then when we're done, we're just gonna return nums. Okay, guys, so that's the quick sort function, right? It's just that now we need to create a partition. So how do we sort this thing? How do we then get all the small element on the left side? How do we get all the elements that are greater than the pivot on the right side? That's what we're gonna be building now. So partition, as we can see, it takes all of these 3 elements, right? It takes L, R, and nums. So the first thing that you want to do is that you want to create a pivot. I told you that the pivot can be any number, but for simplicity, we're going to make it the last element. So pivot is going to be equals to nums and R. Okay, we're going to have another concept called pointer. I think for this one, I want to take you to a whiteboard because I feel like it might be quite complex for you to understand it from code only. So essentially what I meant by pivot and pointer, because I feel like those are two most of the important concept also. So because we had an array, we can think of it as 1, 5, 4, 3, and 2, right? So let's assume that probably 2 was our pivot, right? So we're going to select pivot as our 2, but we also need to select what we call a pointer. So we're going to have a pointer. So you can think of, it's going to start at the first index. So I'm just going to say pointer, and we're going to have another variable called I. So I is just essentially going to loop through towards the entire array, right? So we firstly check if the element at the first index, it is less than or equals to pivot, right? So you can think of it as like we're saying 1 is less than or equals to pivot, right? Which is 2. So if this is the case, then we want to then swap 1 and I, swap these two. I is currently pointing at, I is pointing at 1. I is pointing at 1 currently. So you're going to swap these things. It's not going to make any difference. So you increment I. I is going to point at 5 this time. I is going to point at 5. Pointer is still on, it's still pointing at the first index. and we ask ourselves the same question: is 5 less than or equals to 2, right? If this is not the case, then you just increment this. So you go to 3, you ask yourself the same question: is 4 less than or equals to 2? No, it's not. Then you go to 3. Is 3 less than or equals to 2? No, it's not. Then you know that, okay, 2 and 5 must change, because we know that the pointer was pointing towards this, because we changed this, we changed 1. So the pointer was pointing towards 5, and I is currently pointing at the last value. At 3, I meant to say. Right? You change these two values. So what will happen when you change them? You're going to have 1, you're going to have 2, and you're going to have 4, 3, 5. So you see what happened? We sorted these things. Pivot now became here, and all the element on the left are less than the pivot, but all the element on the right are actually greater than the pivot. Okay, cool. Now that we have the pivot, which we said is going to be the last value, then now we need to get the pointer. So I'm just going to call this pointer, which is going to point towards the first element, right? Then we're going to say for I in range. So I essentially is going to be pointing towards the element that we currently iterating at, right? Oops, I can't type today. Okay, so range LR. Then we're gonna say we're gonna write the condition if the current element that we add. Oops, I think I missed in here. Cool. If the current element that we're currently iterating at, if it is less than or equals to the pivot, then we wanna shift it towards the left. So how can we shift it towards the left? We just need to swap. So we just need to say nums I is gonna be equals to nums where the point is pointing towards. Okay. So to swap in Python, you can just do something like this: pointer, and you're gonna say nums I. Okay. So I think this is called nums. Perfect. So every time we swap these, we want to increment the pointer, meaning that we want to move the pointer so equals to 1. So what did we just do here? We just said, if we have, just to give you an example, we have this, right? Let's assume that our pointer at this point probably was 4, right? If it was 4, then we just check the first element, 3. That's what we're doing here. We're just checking the first element. Is 3 less than or equals to 4? Yes, it is. So what we need to do is that we then need to swap it with the current pointer. So the pointer initially point at index 0. So it's fine. It's just going to swap itself. So it's fine. Then both of the pointer and the index, they're going to move to 5. And we're going to ask our same question. Is 5 less than or equals to pivot? No, it isn't. So I is going to move here. I is going to move to 5. However, pointer is going to remain on 5, right? Pointer is going to remain on 5. But this I here will go to 2, and we'll say, is 2 less than or equals to pointer, right? Then, yes, it is. Then swap these two. That's what we're doing. Swap 2 and pointer. Pointer was pointing at 5 and 2 was here. It's going to swap them. So now 2 is going to be here and 5 is going to come to this point. Okay? Then this will be done. But you see where the pivot is. We need the final step. Okay? We're going to need the final step. So what we need to do now is that, since we know that we have actually made sure that all the elements are on the left side, which are smaller than the pivot, and all the elements that are greater than the pivot are on the right side, the only thing that is left is just to get the pivot to be on the middle, right? So how can we make it to be the mid value? So we just need to say, make sure that we're outside of the for loop. So we just need to say nums because we know that the last element, which was pivot, is nums r, so we just need to say equals to nums pointer. So wherever the pointer was, just make sure that that's going to be the last element. So we're just swapping these values essentially. So it's like me saying getting the pivot and getting it to where the pointer was. Okay. So we're just gonna do that. And when we are done, we just need to return the pointer. Okay. And yep, I think that's all. We can actually have this function. We can actually have this function whereby we have the array, and we can call quicksort. We're gonna give it 0, and we're gonna give it the length of unsupported array, which is unsorted array -1, and we're gonna give it the array itself. It looks like it worked, but just to make sure, because it looks like I didn't give it the just to make sure that the array that I'm giving it is actually unsorted. Yeah, it works. So yeah, guys, I think that's all. If you definitely understand these 5 algorithms, I think you kind of like have the core understanding of the sorting algorithms. There is bucket sort, which we did not cover, so there is quite certain algorithm, but I'll say if you understand these ones, I think you should be good. With that, guys, thank you for watching. I really appreciate it. Bye.